Good day, everyone. You are welcome to today's lesson. And in today's lesson, we are going to continue once again from where we left off. Okay, in our previous lesson, we were looking at products, okay, and quotient rules of differentiation. Okay, so the major topic that we are looking at is calculus, but okay, the first subtopic, okay, will be differentiation. We've done some rules, okay, of differentiation, and the last meeting we did two more rules, products, okay, and quotient. Okay, we ended up with the quotient rule, and just as you have on your screen, you can see that, okay, for the quotient rule, we're looking at these three examples. Okay, I think we did A, B, and was C. So the the solution that you have here is that of the C. So we are going to continue to better our understanding. So please, if you have any issues, okay, don't hesitate to let me know. And if you are yet to subscribe to my YouTube channel, okay, this is the time for you to do so. Okay, so subscribe, like, and share. And if you have any other comments, you can let me know via the comment section. Okay, so as usual, stick and stay with me, okay, whilst I walk you through, okay, today's lesson. So let's see. Okay, we did A up to what? Up to C. So we are going to continue. Okay, none of the questions there is in red. So it means probably, okay, we'll handle all the questions together. So now let's see. Okay, so we have D. Let me bring the D here. So I'm going to look at, oops, let me go back. Okay, so D. Okay, as usual, you extract the function that you are asked to differentiate. So that would be y is equal to what? X, okay, plus 1 over, okay, 2x minus 1. So once you see a binomial in the denominator, okay, you should, and that binomial, one of the terms is what? A variable term. Then you should know that you cannot avoid the quotient rule. If you had only a monomial and that monomial was what? A variable term, then okay, you can use or avoid the quotient rule as previously okay told. So in this case, we can't avoid. Forgive me. So we are compelled to use the quotient rule. And per the quotient rule here, we are going to differentiate straight away because we can't work on this function. So because we've been given y and we are asked to differentiate with respect to x, it means we'll end up getting d dx of both sides. So d dx of y we know will give us dy dx. So indirectly, I'll write therefore my dy dx, okay, will be equal to d dx of this side. I'm going to write it, okay, especially knowing, okay, we have new students on board. So d dx of this side as well. And what you have there is x plus 1 over what? Over 2x, okay, minus 1. You can choose to put it in brackets or not because it's a single fraction. If it's more than a term, okay, then you are compelled to put it in brackets. Okay, so in this case, I'm going to have this will be equal to my differential operator is affecting, okay, quotient of what? Of function. That is a rational function. So in this case, I use the quotient rule. The quotient rule says that I hold my denominator function, which is 2x minus 1. But because it's a binomial, I put it in brackets. Then come and differentiate my numerator function. So I'll find d dx of my numerator function. My numerator function is also a binomial. I put it in brackets. Okay, but that's not all. Minus, then I come and do the swap. This time I will hold my numerator function, which is the s plus 1. Then come and differentiate the denominator function, which is d dx of my denominator function, which is what? 2x minus 1. Also in bracket because it's more than a term. But that is not all. The whole of this over, okay, your denominator function squared. So what's your denominator function? 2x minus 1, okay, squared. All correct, my professors.
Yes, please.
Okay, so remember the first set of examples that we did, you could see a monomial, okay, divisor and that monomial variable divisor. In that case, I said you can avoid, but here you cannot avoid. And with that one too, remember I told you, if you take the denominator squared, you can use the power to, okay, so this one gives us s to the power 4. okay, as we have here, because it came from S squared or squared. If it is a binomial, okay, more than a monomial, please don't expand. Keep it just as you have it there. Meaning don't push the power, okay, through or inside the bracket. Leave the power outside the bracket. You only, okay, push the power inside the bracket when you have a monomial, okay, divisor, which is what? A variable divisor. Please take note. So at this point, this is what we need to do. So it means my next step, my denominator will be intact. I'm not going to touch my denominator. So my denominator will be 2x minus 1, the whole of that squared. My professors, I hope you are following.
Yes, please.
Then I come to my numerator. My numerator, this one is not affected by any operator. So I keep my 2x minus 1. I'm talking about differential operator. Then I come and differentiate x plus 1. So indeed, the x of x plus 1 will give us, my professors, let's go. Differentiate 10 by 10. So that will give us, hello? 1. Okay, very good. 1. Okay, so then minus, you come and hold your x plus 1. So x plus 1 held. Okay, then you differentiate, okay, this one because it's being affected by this differential operator. So 10 by 10, differentiate 2x, you differentiate minus 1. So if you differentiate 2x minus 1, what do we get?
2.
2. Okay, very good. I hope everyone is following. My professors, are you all on board?
Yes, please.
Okay, so now what do we do? This will be equal to, so the next thing that you write, again, keep the denominator. So the denominator is already in its factorized form, so that if you have any simplification or reduction, you can easily do so. Never expand. So now I come and expand this, my numerator. Okay, this 1 times 1 will give me 2x minus 1 itself. Then, okay, I'm going to get 2 times all the terms here, but it will be minus. So I'm going to get minus 2 times each of the terms here. So that will give me minus 2 times x. That will give me minus 2x. Okay, minus 2 times 1. That will give me minus 2. I hope you are with me.
Yes, please.
My professor, is everyone with me?
Yes, please.
You agree? Okay, so now what do we have? So we are going to get this to be equal to, the denominator will be intact. Okay, never expand as advised. Okay, don't listen to that spirit that will tell you to expand. Never. Okay, so I'm going to simplify my numerator. My numerator, I can see plus 2x minus 2x, so that will cancel. Then I like times, if I combine, that will give me 0. Minus 1 minus 2, so if I combine, that will give me minus 3. All correct?
Yes, please.
Okay, so it means this then becomes the differential of what? Of this function. So if you differentiate, okay, x plus 1 over 2x minus 1, you get minus 3 over 2x minus 1, the whole of that squared. Point well made.
Yes, please.
Okay, so let's go and do, okay, 2 more. Okay, I think this one will do it together, and even this one. So please, I want you to get involved. Okay, so let's go and look at what the E. Okay, before E, any question? Any questions, my professors? So we are fine. Okay, so let's move. Okay, Prof. Ernest.
Sir, if later on we'll come and expand the denominator, why is it that we don't expand it when we are still at the early stage of solving the question?
No, we never expanded the denominator, whether later or now. We never expanded.
So we always leave it the way it is.
Yes, you leave it if it is more than a term. Because if it is, okay, if you have an algebraic expression, remember I told you, if you have an algebraic fraction, I should say, if you can reduce, the denominator and the numerator should all be in their factorized states before you can see that reduction is possible. You remember?
Yes, please.
But the denominator here is in its factorized form. Can you see that?
Yes, please.
So it means if you go and expand and you want to verify whether you can, what do you call it, reduce, you have to go back and factorize again. And that will be a useless work. I hope you get my point now.
Yes, sir.
So with this one, the numerator was not in its factorized form. okay, for us to see whether reduction is possible. So we had to, okay, expand combined item, just as we did in this one. We expanded, we combined item, and that gave us this. So at this point, we realized that, okay, the numerator, this is an algebraic fraction. If this could be reduced, then I should be able to factor out something in the numerator that will cancel something in the denominator. And we realized that, yes, that's possible. If I factor out x, okay, it can come and cancel one of the x's in the denominator. So that, therefore, we go and factorize. You get the point?
Yes, sir.
All right, so never expand your denominator. Keep it just as you have it there. If you see it in any other books, okay, still, if the book has it in its expanded form, okay, please, you shouldn't expand. Unless it's an objective question, and the objective question, you don't see this, but you see its expanded version. Then what do? You expand what you have there and check or compare with what the options that you have in your objective answers, and see the one that correspond or is the same, then you pick it. Otherwise, never expand. All correct. And
Yes,
remember,
sir.
I gave you the same advice when we were doing the differentiation from first principle. It's the same. Okay, only that this time around we are using the rules to make the work very easy for us. Okay, so if that's the case, then I guess we can move on. NS, we are fine, Abi. Okay,
Yes, sir.
so now let's go. G of x, that's what we are giving. Okay, and we are told is equal to x minus 1 over, okay, 2x minus 1. Oh, x minus 2. Okay, other than that, I would have. Okay, so you can see that this question is similar to this. Your numerator is linear, your denominator is also linear. Okay, so the same idea. We are going to find d dx of both sides. So d dx of j of x we know will give us j prime of x. So we are matured enough to write therefore, okay, j prime of x, okay, will be equal to, then now it will be d dx of this side. So I'm going to write it d dx, or if you are matured, like I said, hey, who was that? Okay, so this is what we have. Hold the denominator. Okay, I guess I can skip the d dx of the side. Okay, and you will be fine. Oops. Okay, Prof. Fifi. Okay, thanks for alerting me indirectly. So let me clear that. Okay, then come and go and, okay, disable man annotation. Okay, so now, okay, I'm writing it. So d dx, but I've told you, you can, oops, what is happening? Okay, you can skip what you have there. So d dx of what? Of my x minus 2 all over what? 2x, okay, minus 1. So if I like, I can put it in brackets, or it's not necessary. Okay, I wouldn't. Okay, so now this would be equal to, okay, remove, your operator is affecting quotient. So hold the denominator function, which is 2x minus 1 is a binomial, you put it in brackets. Okay, then differentiate the numerator function. So it will be dx of my numerator function, which is what? X minus 2. Okay, but that's not all. Minus, come and swap. So I'll hold the x minus 2, my numerator function, then differentiate the denominator function. And my differential operator is d dx. So d dx of my denominator function, which is 2x minus 1. But that is not all. The whole of this over, okay, my denominator function, 2x minus 1, the whole of that squared. Alpha.
Yes, please.
Okay, I hope my handwriting is legible, apart from the fact that I'm using, okay, I'm writing the X, okay, the way that I asked you not to write it because of my digital pen. Okay, hey, Prof. Gideon.
So please, in our second step, the dx of the function x minus 2 over 2x minus 1. So please, in the
This,
previous
this,
examples,
this one, remember this is your first step. This one, in actual fact, is not a step. This one is just copy and paste. So your actual input starts from here.
So please, but in the previous examples, we didn't put it in brackets.
Oh, but I said it. I said you can ignore, and I even stated that, okay, it will be better for you to ignore. So you let me ignore because it's just a single fraction, you can ignore. Okay. And it will not be costly. Okay. It's a single fraction. But if it's more than a term, okay, then, okay, you cannot ignore. Is that clear? And some of you would want to put it in brackets. If you put it in brackets, it will not be costly. The only thing is that, okay, it will be time wasted. You don't write what is not necessary, basically. Afa.
Yes, sir.
And you can see that this one, okay, this one, let me see if I can. Okay, so this one, you have it in bracket, because it's more than a term. Your operator is affecting more than a term. Every single fraction is a single fraction, so it's a term. Do you agree?
Yes, sir.
So that's why I ignored. Okay, but that's not to say that if you bring the brackets, it will be costly. So now what do we do? The denominator will be kept. So I will go and do where there will be less work or little or no work. So 2x minus 1 squared as my denominator. My numerator is where I'm going to work on. So I keep my 2x minus 1. Okay, so binomial, I put it in bracket. Come and differentiate, okay, x minus 2. And that will give us 1. Do you agree?
Yes, please.
Then minus, you come and hold your x minus 2. Then differentiate 2x minus 1. And again, that will give us 2. Okay, so you can see that never expand the denominator. So I'm going to write the denominator. It's already in its factorized form. So 2x minus 1 all squared is the numerator that is not in its factorized form. Okay, so I go and expand and factorize if necessary. So if I multiply this, I'll still get 2x minus 1. Okay, then if I come and multiply this, forgive me, it will be minus 2, okay, times x, or it will be minus 2 into x minus 2. So that will give us minus 2 times x, which is minus 2x. Okay, then minus 2 times minus 2, and that will give us minus 4. Sorry, plus 4. All correct.
Yes, please.
Okay, so again, your minus 2x and the 2x here will go. Okay, so it means my next step, which probably will be my last step, okay, will be my denominator is 2x, okay, minus 1, the whole of that squared. Okay, and my numerator will be, okay, 2x minus 2x, that will go. Minus 1, okay, plus 4, and that will give us positive 3. The other one give us negative 3. All correct. Okay, Prof. Joshua.
Sir, please, the third step, 2x minus 1, the bracket. I don't understand how you got for the 1.
Oh, okay. So if I give you this to differentiate, x minus 2 to differentiate, what do you get? You differentiate term by term. So you differentiate x. If you differentiate x, remember if the power is 1, the coefficient is what becomes the answer. Okay, if you differentiate a constant, you get 0. So you get 1 minus 0. 1 minus 0 is 1. So you write it there. Prof. Joshua, you've gone beyond this. So these are simple functions that, okay, you should be able to differentiate with ease.
Okay, sir.
Okay, all right. That notwithstanding, if you have issues, still let me know. All right. Okay, so it's the same thing here. Differentiate term by term. Your operator is affecting, okay, more than a term. So you differentiate term by term. And each term, the nature of the term will tell you the rule that you are supposed to use. Okay, so here, okay, x to the power 1. So it means, okay, if I differentiate, I'll get only the coefficient. A differential of a constant will give me 0. So that will give me 2 minus 0, which is what? 2. You don't write the 0, so you just put the 2 there. Is that clear? Okay, so now the one that maybe will involve a little more because the denominator is a quadratic function, but no issues. We will end up using the same concept. So f, the last one for this particular set. Okay, so f, what are we giving? Okay, and please take note with this one, if you come and conclude, okay, dy dx, you are wrong. And the assignment that I asked you to mark, I explicitly told you that if you use dy dx, mark, give your final answer, which is the A2 mark, okay, wrong. And some of you, I don't know whether you watched the video before marking or you just marked. You didn't go by the instruction at all. And I'm going to be hard on you, okay, when I am marking and giving you the feedback myself, because you have decided not to, okay, listen attentively and do the right thing. Okay, so that is just to prompt you. Okay, so now what do we have? The last one is what? F of x. So f of x, okay, is equal to, okay, 2x minus 3 all over, okay, s squared, okay, minus 5. Okay, so this time around, it's still a rational function, a quotient rule, a function of another function. Okay, however, your numerator is linear, your denominator is what? Is quadratic. But it's the same concept. Okay, so in this case, what do? We are finding ddx of f of x, and that will give us f prime of x. So I'll write, therefore, if I take ddx of f of x, that will give me f prime of x. Okay, we know. And that will be equal to ddx of this. So, okay, ddx of what? My 2x minus 3 all over, okay, my s squared minus 5. Okay, if you like, you can put it in brackets. I think it's not necessary. It's just a single fraction. Know your operator. Okay, now this will be equal to, my operator is affecting quotient, a function over another function. So I hold my denominator function, which is the s squared minus 5. Okay, I put it in brackets, more than a 10. Come and differentiate my numerator function. So ddx, okay, of what? 2x minus 3. And those who are matured can do the ddx of the 2x minus 3 straight away and write it there. Okay, so the person can write in bracket 2, who know that you have differentiated. Then minus, okay, you come and hold the numerator function this time around, and that is what? 2x minus 3. Then come and differentiate the denominator function. So it will be ddx of your denominator function, which is s squared minus 5. I hope you are following my professors.
Yes, please.
Okay, but remember, that is not all. The whole of that, okay, all over, the whole of that over what? Your denominator function squared. The denominator function is s squared minus 5. So it's a binomial, you put it in bracket, then you square. Even if it's a monomial, you put it in bracket, square. All right. Okay, so now what do? We are in a comfortable lead. Remember the advice, never expand the denominator. So it means my next step, my denominator will be intact. So I'll write x squared minus 5, the whole of that squared. Then come to my numerator. My numerator, I have s squared minus 5. That I'm not differentiating, so I hold it. Okay, then come and differentiate this. Okay, Prof. Joshua, if I differentiate this, what do we get? Or if you differentiate this, 2x minus 3, what are you supposed to get? Convince me that you've understood. Okay, Prof. Joshua.
Say again, 2.
You get 2. Very good. Okay, all right. Prof. Carl, were you going to take the wind out of Joshua's sail?
No, so not like that. I just wanted to answer
You wanted to answer?
Yes, please.
So that's the more reason why I mentioned his name first. Okay, usually, okay, I don't have to mention the name before asking a question. Because I wanted to direct that one to him. Okay, that's why. So the next one will be 2x, okay, minus 3. Okay, then if you differentiate this, let's do that together. That will give us the term. If you differentiate this term, no,
2.
no.
2x.
2x. So immediately you write 2, you are doomed. Okay, it means that step from that step going. So it will be 2x. Then if you differentiate the constant to give you 0, so you end there, then close it. So that will be equal. So you have to be very careful. Any term, immediately one of the terms is wrong, you are going to get M0, A0. At that point, marking becomes so easy. So denominator kept intact, s squared minus 5, okay, all squared. Okay, now you go to your numerator. If you expand this, you are going to get 2s squared, okay, then minus 10. Do you agree?
Yes, please.
If you expand this, we are going to get, if this 2x comes here, it will be minus 2x times 2x, and that will give us what? Minus 4s squared. Do you agree?
Yes, please.
Okay, then you get minus 2x times what? Minus 3, and that will give us positive, okay, 6x. All correct?
Yes, please.
Okay, so now, okay, we are, okay, almost done with our last step. Okay, so what do we have? Denominator intact, never expand. Don't listen to that spirit. That will tell you to, okay, expand. It's not a good spirit. So now you come to your denominator. So numerator, you work on it. okay, 2x squared, okay, minus 4x squared, and that will give us minus, okay, 2x squared. Do you agree?
Yes, please.
But I will hold on because that's not the only term. Remember, I said if you can avoid starting with a negative term, you avoid. Okay, so then it will be my constant term, only one constant term, only one term in x. The constant is also negative. I can't start with it. That is positive. So I will come and write my 6x, the positive, then now introduce my negative. So my negative, okay, 2x squared can be introduced, then what? Your minus 10. Or you can introduce your minus 10, then what? Your 2s squared. Your minus 2s squared. Is my point well made? So you
Yes.
can see that as I write, I think before writing. Other than that, the person will come and start with a negative, and later we'll have one more step, meaning you have to go and arrange, okay, because you can see a positive term, okay, in your numerator. So you start with a positive term in your conclusion. Okay, so you have one more step if you don't think before writing. Okay, point well made. Are we all fine?
Yes, please.
Yes, sir.
Okay, all right. So from here, this should have been okay. That so let's go and look at a more complex situation. Okay, so then if you do A and B, you are able to do that. Okay, C, you should be able to do it. Okay, I will guide you, and that will be your assignment. Okay, once it's in red, most likely you'll see it in your assignment. Okay, so quickly, let's go and look at question 4. Find the derivative of the following. So I'll write 4. Okay, major question number 4. Okay, minor question number, okay, A. What are we given? Y is equal to 3x, okay, minus 7, all over, okay, s squared, okay, plus x. Okay, so once again, you can see, so only that this time around, the nature of the question, I'm talking about how, okay, this statement is given. You are asked to find the derivative of the following. So the other one, you knew the variable that you were differentiating with respect to. Okay, so you were told differentiate with respect to x. Okay, this question is silent on the variable that you are supposed to differentiate with respect to. But you should know, okay, that indirectly, okay, the variable that you differentiate with respect to will be the variable that your function depends on. So y depends on x. So it means if you are differentiating, you have to differentiate with respect to x. All correct, my professors?
Yes, please.
So you always, unless otherwise stated, you always differentiate with respect to the variable that your function depends on or your relation depends on. Okay, so now what do we have? We are asked to, because the function depends on x, indirectly we are asked to differentiate with respect to x. So it means we are going to take d dx of both sides. So d dx of y will give us dy dx, we know, all over. So that will be equal to, then it will be d dx of this time I'm going to handle it maturely. Okay, let me write the d dx first. Okay, so d dx of what? My 3x minus 7, okay, all over, okay, s squared, okay, plus x. Okay, so unlike this one also, you have the numerator to be linear, your denominator, okay, to be quadratic, but it's somehow different from the other one. The other, where we just came from, the denominator, which was a quadratic function, okay, had only one variable term, okay, which was the quadratic term. Here you have two variable terms. So meaning, okay, you are going to get two terms, most likely when you differentiate. Okay, most likely. Unlike the other one, when we differentiated, we had only one term. Therefore, the multiplication was so easy for us. So now let's go. This will be equal to, so I'm going to handle it maturely. The rule says I hold the denominator function, so I'm going to hold s squared plus x. It's a binomial, I put it in brackets. Then come and differentiate my numerator function. So if I find d dx of x minus 7, that will give me 3. So of 3x minus 7, that will give me 3. Do you agree? Hello, my professors. Do you
Yes,
agree?
please.
Okay, then that's not all. Minus. I come and hold my numerator function. Okay, it's a binomial, so I put it in bracket. 3x minus 7. Then differentiate my denominator function. If I find d dx of s squared plus x, it means I will differentiate term by term. So that if I differentiate x squared, that will give me 2x. Do you agree?
Yes.
If I differentiate x, what will that give me or give us?
1.
1. So it will be plus 1. Okay, so all over. I hope you are following my professors.
Yes, please.
Okay, all over your denominator, which is the s squared plus x, the whole of that was squared. Okay, all right. So remember, we are not going to touch our denominator. We are not going to touch our denominator. I've seen somebody. Okay. Oh, somebody said you are not hearing. Are you able to hear now? Maybe if you are not hearing. So please let me attend to this person. So please, if you are in class, I've told you, don't send a message via the chat unless maybe, okay, I've instructed you to do so. Okay, so it's possible I have attended to the person late. So if you cannot hear me, maybe I can hear you. So you just put up your hand, I will call you. If I call you and you talk and, okay, I can't hear you too, I will let you know. Oops, okay, so let's go. So this will be equal to, now, okay, the denominator will be kept intact. So that one, that's what I'll write first. Okay, little or no work first. So the whole of this one squared. Then I go and work on my numerator 3 times. Each of the terms here will give me 3x squared, okay, plus 3x. All correct. Okay, so
Yes,
unlike
please.
the other one where we ended up getting a monomial times a binomial, therefore the expansion was so easy. Here we have 2 binomials, but they are not special binomials. So it means I am compelled to distribute. So what I will do is I will keep my negative, okay, out, then come and multiply. So it will be 3s times 2s, and that will give me 3s, 6s squared. Okay, those who are matured can push the negative and do the expansion together, but please tread cautiously. So I will advise you go by the same way. Then this one times this will give us what? Plus 3x. Then minus 7 times, okay, 2x will give us minus 14x. Then minus 7 times 1 will give us minus 7. All correct, my professors?
Yes, please.
Okay, so now you come to your next step. So that will be equal to, okay, so your denominator intact, s squared plus x, the whole of that squared. Okay, then your numerator, you already have 3s squared, okay, plus 3s. You go and remove your final set of brackets. So this will be, okay, this multiplying all the terms here. But I will combine before multiplying. So in my mind, I will combine this. Okay, and I know that this will give me minus 11x. Do you agree? So I'm going to get minus 6x squared. Okay, then it will be minus, okay, times minus 11, okay, s, and that will give me plus 11x. After I have combined these two, then push the negative through. Okay, then minus times minus 7. So I'm going to get plus 7. Afa. Hello, my professor is Afa.
Yes, please.
Okay, all right. Okay, so let me see whether the person has responded. Okay, all right. So, okay, we thank God. Okay, that you can see. All right. Okay, so now the next step. Okay, let me come and continue here. Or let me see if I can make use of this space. So this will be equal to the next step, keep the denominator. So you are going to combine like terms in the numerator. Okay, so s squared plus x. Never expand, okay, the denominator if it is more than a term to a certain power. So now what do we have? 3s squared minus 6s squared. That will give me, okay, minus, okay, 3s squared. But I will keep that because I don't want to start with negative if possible. So in my mind, I'm keeping minus 3x squared. Okay, so that has been shelved. Okay, so now what do we have? 3x plus 11x. So I know that will give us what? 14x. So I will start with that one. That is positive 14x. Okay, then I'll go and bring what I shelved to the minus 3x squared. Okay, then bring, okay, the constant that I have here is 7. Okay, so that will give us what? Plus, okay, 7. Okay, so this will be 8, okay, for the differential of what? Of the function that we have there, the y. How far?
Yes, please.
Okay, especially, okay, the one who said, let me see the name. Okay. Is it Fasasi? Did I get the name right? Okay, you couldn't hear from the beginning, but are you able to relate?
Yes, sir.
Okay, we thank God. All right. Okay. So now, what do we have? The last question for all of us. And that will be, so you can see that this time around, it's quite complex. Okay, numerator is quadratic, denominator is also quadratic. Okay, so if you're able to do it by extension, irrespective of the nature of what your numerator function, denominator function, you should be able to do it. Okay, so B, what are we giving? Y is equal to 2x squared, okay, plus 5x minus 2 all over. So this time around, 5x minus 2. Okay, to involve a little more work, 6x, okay, minus x squared. Okay, so we are asked to differentiate. The y depends on x. So it means, like I told you, you are supposed to differentiate with respect to x. So the operator will be d dx. Okay, Prof. Frank. Hey, Prof. Frank, unmute and.
Sir, please, I see plus or minus x in the question.
Oh, you see rather minus plus.
Yes, sir.
Okay, I will change it. I think it was a typo error. So I will have it changed. Okay, let me do it now before I even forget. Okay, so let me pause then do the needful. Okay, thanks for drawing my attention to that. Okay, so the correction has been made. Okay, it wasn't supposed to be plus or minus, minus plus. Okay, so that there is a difference. Plus or minus is this. Okay, and this one is minus, okay, plus. You read from top to down. All right. Okay, so now that we have the corrected version, okay, which conforms to what we have here, let's go. So I will have therefore, okay, if I'm asked to differentiate, okay, find the derivative of this, which we know you are differentiating with respect to x, it will be d ds of both sides. So that will give us dy dx here, okay, and that should be equal to d dx of this side. Okay, so I am going to, if I differentiate this, okay, so you let me write the d dx, okay, of the 2s squared. You could have skipped that step too. Okay, so let me even skip so that you know. Okay, you let me write it. Okay, I've made my point. So if you skip, it will not be costly. Okay, so when you are applying the rule that we cannot skip. So here we are applying the rule. So we hold the denominator function, which is what? 6x, okay, minus what? X squared. Then come and differentiate my numerator function. Okay, so if I differentiate my numerator function, I am going to get, if I differentiate, I'll differentiate 10 by 10. So let's differentiate together. Hey, my profs. 10 by 10.
4x
4x
plus 5.
plus 5. Very good. Okay, then minus, come and hold your numerator function, which is what? Your 2x squared plus 5x, okay, minus 2. Then differentiate your numerator function. The denominator function. If you differentiate the denominator function, what do we get?
6
6
minus 2x.
minus 2x. Very good. Okay, but that's not all. The whole of this over your denominator function squared. My professors, I hope you are following.
Yes, please.
Okay, very good. So at this point, we are in a comfortable way. You cannot see any differential operator. The function that you needed to differentiate, you have differentiated them. This one, okay, and this one. So we will go and what? And, okay, expand and combine like terms, if any, in the numerator. But the denominator will be kept intact. So 6x minus x squared, okay, the whole of that was squared. Okay, so now what do? We come and expand. So this time round too, you can see that you have a binomial multiplying a binomial. Okay, a binomial multiplying a binomial. The first set of questions, you had binomial multiplying a monomial, binomial multiplying a monomial. But here, we had binomial, monomial, binomial, binomial. So now we have binomials multiplying. So it just tells you that, okay, a little more work will be done in terms of your expansion. That's all. Because multiplying a monomial and binomial is easy, okay, easier compared to multiplying two binomials. So now what do we do? Let me make my bracket, okay, neat there. Okay, it wasn't pretty at all, so let me clear the old one. Okay, all right. So now let's do it together. 6x times 4s, so we are going to distribute. 6x times 4s will give us
24x squared.
24x squared. Okay, then 6x times, okay, 5.
30x.
30x minus s squared times 4x.
Minus 4x.
4x to the power 3.
Okay, s cubed, that's the matured way. Okay, then minus s squared times 5.
5x squared.
Minus 5x squared. Okay, then we come and distribute here too. Okay, this time around, again, I'm going to keep the negative. Okay, so that I will advise you to do so, to play it safe, because immediately one of the terms wrong, asemwaba. Okay, so I will keep the negative, then my bracket, and come and distribute. Here, okay, I didn't introduce bracket there because my coefficient was positive 1. So even if I kept bracket there, okay, then I come and expand with the 1, I'll end up getting the same result. But here the coefficient is not 1, it's minus. So what do we do? 2s squared times 6 will give us what? 12s squared, am I right?
Yes, please.
Okay, then 2s squared times minus 2s will give us what? Minus 4s cubed. Okay, then we come and get what? So this one is going to give us more terms. So you can see that I've started squeezing. Okay, so I come and get 5x times 6. Okay, will give us what? Again, 30x. Am I right?
Yes, please.
Okay, then 5x times what? 2s will give us what? Okay, times minus 2s will give us minus 10x squared. Am I right? Okay,
Yes,
it seems my terms are not
please.
going there. Don't worry. Okay, I should have pushed it to the side, but I can still make my point. Then the next one will be minus 2 multiplying all the terms here. So I'm going to get minus 12. Okay, I'm going to put the result down. Then, okay, plus, okay, you cannot do that. You are supposed to. You have more space to work with. Okay, then I'll get plus 4x. Do you agree?
Yes, please.
Okay, then I close my bracket. So the next step, I'm going to write close to the margin. Okay, so now knowing that I will need more space. Okay, so never mind what I have here. If you understand, that is fine. Okay, all right, so now what do we have? 6x, okay, minus x squared, the whole of that squared. Okay, so now let's go to the numerator. The numerator, we are going to get, okay, 24x squared will be intact. Okay, plus 30x will equally be intact. Then minus 4s cubed, okay, will be intact. Okay, minus 5x squared will equally be intact. Then I come to, so let me see if I can combine like terms before I push the negative through. So 12s squared minus 10s squared, and that will give me 2s squared. Then it will be minus, so I'll push the negative 2. So that will give me minus 2s squared. Do you agree?
Yes,
Okay,
please.
Prof. Frank.
Sir, please, what if you put the 24x up to 5x minus 5x squared in a bracket and like
Which one?
simplify it before,
Which
like
one?
yes, please.
Oh,
And
you could
simplify
have done so. You could have added 24s squared, then the minus 5s squared there. You could have added.
Okay.
You can combine like terms here. Okay, just like I'm doing here. In any case, that would have been the ideal way. Okay, so that you write less. You get the point? So you can do, so all that we are doing is expanding and combining like terms. Okay, so where you can obviously see like terms and combine. Someone can also do this way, expand this, okay, keep all the terms here, then later come and combine all the terms, rather than me combining and pushing the negative through. Do you get my point?
Yes, sir.
So someone could have done negative to all the terms here, then later will come and combine, but I'm combining before pushing the negative through. Okay, so now we've done the first one, the s squared. The s cubed, we have only one. Am I right? Okay, so only one. So that will give us minus times minus. So that will give us positive 4s cubed. Okay, then we come to the x term. X terms, we have 30x. Is there any other term here that involves x? And then that is this. This is 4x. Only that it didn't appear well, right?
Yes.
Okay, so it will be 30x plus 4x. So that will give us 34x. Then you come and push the negative through. So that will give us minus 34x. All correct, my professors?
Yes, please.
Okay, then you come to the constants. Only one constant, which is the minus 12. But it will be times minus. So that will give us, okay, plus 12. So we've removed, okay, the bracket. So at this point, I think you should be able to proceed. So I will just write, okay, the denominator intact. Then you go and combine the numerator, okay, like terms, okay, or simplify the numerator by combining like terms. Okay, so you just go and combine whatever that you get, you write it here, and you are done. Afa. Okay, Prof. Joshua.
Yeah, please, you've made a mistake. It is not 2x squared, it is 12x squared.
For which one? Okay, thank you. I said 12, then I wrote 2. No, let me see. No, it is 2. It is plus 12s squared, then minus 10s squared. You combined.
Okay, sir.
So it is 2.
Okay.
All right.
Thank
okay.
you.
Okay, Prof. Benjamin.
Sir, please, where the 34 is, it should be plus 34 also. Yeah.
Where the 34 is?
Yeah, it should be plus positive.
No, you can see that the 30x then plus 4x, that will give us 34x, but we are pushing the negative through. So times negative. We combine and we push the negative through. Do you get the point? Hello?
Yes, sir.
You get the point now, right?
Yeah.
So you have to be very careful. If you think combining and pushing the negative through will be a problem, push the negative through, then later combine. It's better to play it safe.
Okay, sir.
Okay, all right. Okay. So I guess, okay, with this one, so in terms of the quotient rule, we should okay, be fine. So at this point, okay, I'm going to give you your water break. Okay, so by 8:30, you should okay, be back. So 5 minutes water break. Please don't leave. I'm going to capture the attendance as usual. Okay, so welcome back from the water break. We are done with the quotient rule and also the product rule. Okay, so we are going to look at possibly our last rule. Okay, and I will say this is, for me, I consider this rule as the most important rule of all the rules. In that, okay, if you know it, any sort of function, okay, you will be able to differentiate. Okay, all the differentiation rules that we've considered, especially the constant rule and the constant multiple rule, okay, they all take their source, okay, from this, okay, general perspective. Okay, so we are going to look at composite function or chain rule. Okay, composite function, we've all done functions and we know what a composite function is. Okay, we know that a composite function will be, okay, when we apply 2 or more functions successively. Okay, so anytime here, I will just tell you, anytime you see that you have, okay, a function to a certain power, irrespective of the power, okay, you can use this rule that I'm going to walk you through to easily differentiate. So basically, if you have any function to any power, you look at this from, okay, this, or you look at it from this perspective. Or maybe when we are doing trig function too, you wouldn't see it to be a function to a certain power, but you see a function inside a function. In that case, okay, you can still look at it to be a composite function. Therefore, it will warrant the use of this rule that I'm here to walk you through. Okay, so please, okay, it's a little technical, but not difficult at all. Okay, I'll try to break it down, okay, for you to relate. However, if you're unable to relate, as usual, don't hesitate to let me know. Okay, so this is what the rule says. Okay, if I'm differentiating f of, so I'm finding ddx of f of s to a certain power. So it means I have a function to a certain power. Do you agree?
Yes, please.
Okay, now this is it. Okay, if I differentiate a function to a certain power, this is how I am supposed to do my differentiation. Okay, I bring the power down, you know, okay, the constant multiple. Bring the power down, okay, then what do you do? Or even the power rule, if I should say. Bring the power down, keep your function, then what do you call it? Reduce the power by 1. Is that not it? That's the basic rule that you know for the power rule. Is that clear?
Yes, please.
Okay, however, that is not all. Okay, it's supposed to be times the differential of the function itself. So you can see f prime of x. By that, this is what I mean. Okay, I'm going to write it in another way. So if I'm looking for d dx, okay, of f of x, this is my function, the whole of this to the power n. Okay, this will be equal to, I said, what is the rule? Bring the power down. So I'll bring the power down to come and multiply my function. So my function will be f of x. But that is not all. Then times d dx of the function itself. So d dx of f of x. And that is the rule that we use in, okay, all functions basically. Okay, so listen. If I give you s to the power n, and I ask you to find d dx of this, okay, what would this be equal to? Remember the rule, the power rule. Let's go. The power rule. Bring the power down, n, x, reduce the power by 1, n minus 1. Do you agree?
Yes, please.
You can see that usually, okay, we will end there. Okay, we are ending there because this factor that we should have considered, you can see that this one has another factor. That factor is the differential of what? Of your function. Okay, and here we ignored that because that's, okay, this is supposed to be d dx of the function that we are raising to the power, and the function that we are raising to the power is x. Do you agree? Per this rule, it's supposed to be bring the power down, okay, keep your function, reduce the exponent by 1, then, okay, times d dx of your function, what you are raising to the power. So it will be times d dx of x. d dx of x is what?
1.
1. Okay, so whenever, so you can see that this one, please, the person should mute. Benji, mute. Okay, so please listen carefully. This is the foundation. I want you to relate, okay, and relate very well. So it will be times 1. And if it's times 1, you'll be left with this straight away. So anytime the function that you are differentiating is just x, okay, that factor that you are supposed to, okay, attach will be 1. So usually we don't attach it. But if it was maybe 2x squared plus 1, okay, all to a certain power, the function here, if I differentiate, will I get 1? The function to a certain power, if I differentiate, will I get 1?
No, please.
You won't get 1. So it means that factor must be considered. So anytime you are differentiating and you see x to a certain power, only x to a certain power with nothing attached, that factor is not considered. Okay, so please take note. But immediately, okay, what you have there will give you a result other than 1. If you don't consider it, it will be problem. Okay, so the rule basically says that just like anytime you are differentiating a function to a certain power, you are using, okay, the composite function or the chain rule. There is another angle, okay, that I can explain, but I want to explain it from this angle. Usually that's the angle that students get. If you are unable to get it, maybe your situation will be different, then I will take the second angle. But I know you appreciate it from this perspective or this route. So we are saying, if you look at the example, we said, okay, the word example that we have here, we've been given y is equal to what? Is equal to x plus what? 2 all to the power 4. Okay, so I have a function to a certain power. Do you agree?
Yes, please.
Okay, so once I have a function to a certain power, I can use the composite, okay, function rule or the chain rule. Okay, so if I'm finding d dx of both sides, then I'm taking dy dx of this side, which should be equal to d dx of this side as well. And here I have to put it in bracket. Okay, so to the power 4. Okay, my differential operator is affecting, okay, a function to a certain power. A function to a certain power. So it means I can use the composite function rule or the chain rule. And by that, this is what I'm supposed to do. I'm supposed to bring the power down like the normal one. Keep my x plus 1, the function that I have to a certain power. Reduce the power by 1, and that will give me 3. Okay. Oh, sorry, it's 2. Forgive me. I guess that was why, okay, Caroline's hand is up. Okay, so at that point, I was solving my own question. So I will bring the power down, keep my, okay, function there, reduce the power by 1. So that will give me 3. But that is not all. Okay, times d dx of the function that I raised to the power. The function that I have raised to the power is x plus 2. Okay, so that will give me 4. I will keep my 4. Then the x plus 1 cube. Then come and differentiate. If I differentiate this, I will get 1. And that is what you have here. Okay, but after that, you can multiply the 4 and the 1, and that will give you 4. Then you end up getting 4 into s plus 2, the whole of that cube. So this is the foundation. Okay, if you have a bit of what the understanding, that's okay. We are going to solve more examples, and I will, okay, draw your attention to all that your attention needs to be, okay, drawn to. Okay, Prof. Benji.
Sir.
Mm-hmm.
Sir.
Yes, I'm listening. Oh, yes.
So, it's only differentiation that we can use this rule, or when you find any question like this, you can use this rule to solve it.
I don't get you. Any question like what?
Like maybe you meet it in other topic.
Oh, you are dealing with differentiation that comes with this rule. Binomial theorem doesn't come with this rule.
Okay, sir.
You get it. So if you are given this and it's under banana, you are asked to expand. Okay, your expansion means you know what you are supposed to do. This one is differentiation. So what we are doing here, the rule that we are considering is peculiar to differentiation, not any other topic.
Okay, sir.
Is it clear? Okay, Prof. Caroline.
Mr. Hackman, please, I think you made a mistake because.
Oh, plus two, forgive me.
Yes.
I've started exhibiting symptoms. Okay, you are watching my back. Keep it up. Okay, not that you think, you know I made a mistake. Okay, all right. So it's supposed to be plus 2. Other than that, okay, I won't get the final answer score. I will get some marks anyway. Every little mark counts, so you have to be very careful. Okay, so don't worry. We are going to look at worked example. You'll be fine. So here, the point is, bring the power down, keep your function, reduce its exponent by 1, then multiply it by the differential of the function that you have an exponent attached to it, your original function. Is that clear? Bring the power down, like you are doing your normal differentiation. Bring power down, keep your quantity, reduce its exponent, okay, or its power by 1. Then don't end the times the differential of that function itself. So here we are not going to end there after bringing the power down and reducing the exponents, okay, or the power by 1. Okay, so let's go and look at the following worked example. Remember, okay, we've done this, okay, and this. I think this and either, yeah, it could be this and this, or only this one and maybe this one as well. Okay, where you were asked to expand, you expanded. Is that not it? And you differentiated, you had a result. So let's go and use the power rule, okay, or so I should say the composite function rule, and see if you end up getting the same result. Okay, it's not difficult at all. So differentiate the following with respect to x. So it means, okay, the function must depend on x. Therefore, we can differentiate with respect to x. So what do? We go and write solution to question 1. Okay, after that, we come to A. The minor question number A, what are we given? Y is equal to x minus 2, the whole of that was squared. Afa. So
Yes, please.
this one is just copy and paste. Now we are differentiating with respect to x. So it means we are taking d dx of both sides. So I'm going to have therefore d dx of y we know will give us dy dx. We are now matured enough to recognize that. And this will be equal to d dx of what we have there. So d dx of what? X minus 2 all squared. So my differential operator is affecting a function to a certain power. Is that clear?
Yes, please.
Okay, so that function is a binomial, okay, function. So now what do? Okay, remember, it is the composite function rule or the chain rule that should come to mind. So per that rule, okay, this will be equal to, if I'm applying the rule, I bring the power down. So 2 will come down, all correct?
Yes, please.
Okay, then you keep your function that you are raising to the power. Which function is it? X minus 2, do you agree?
Yes,
Okay,
please.
then you reduce the exponents by 1, so it will be 2 minus 1. That will give us 1. Okay, I'm writing it just for purposes of explanation, but you are matured, you don't write it. Is that clear?
Yes, please.
It's just simply understood be there, but that is not all. Times what? D dx of the function that you have in bracket. So times d dx of what? X, okay, minus 2. So it means I'm going to get, okay, 2 into what? X minus 2. Okay, the power will be 1. I won't write it this time around. Then times d dx of x minus 2 will give me 10 by 10. 1. Okay, so in effect, I'm going to get, I'll multiply the monomial factors. Okay, then, so that will give me 2 times 1, which is 2. Then I will keep my x, okay, minus 2. I don't expand because the question itself came in its factorized form. So I end here. So if you like, go back and see, or we can even do it here. Okay, so let's do it if you expand, where you are asked to expand, that will give us your y, which is equal to x minus 2. Okay, squared. If you expand, what do we get? X squared, and he help me, minus 4x, am I right? Plus 4, do you agree? Hello,
Yes,
do you
please.
agree? Okay, so
Yes,
now
please.
if you are differentiating, then dy dx, okay, will be equal to, you are going to differentiate 10 by 10. So you get 2x minus 4. Do you agree?
Yes, please.
Because the question came in its factorized form, this can be factorized. So we are going to put it in its factorized form. So 2 will come out, then you get x minus 2. Is it not the same as what we have here?
Yes, please.
It's the same. Okay, so using the power rule, we've been able to achieve the same purpose. However, remember, I've told you, usually you will not be restricted. Okay, if I want you to let me know, or I want to bring out your level of understanding in the power rule, and I'm setting this question, I will restrict you. Did I say the power, the composite function? So I will say that using the composite function rule, so that, okay, the other way, which will be you expanding, I mean, this particular way will be out. So if you go this route, you are totally wrong. It means you didn't adhere to the instruction. Okay, however, I've told you, usually the question will be open. If it's open and you can expand, always expand, okay, then differentiate 10 by 10. That's the easiest. So if you can avoid the quotient, you avoid, products you avoid. And now I'm saying that if you can avoid the composite or the chain, okay, rule, you avoid. Point well made.
Yes,
And
sir.
I've told you that it's not in, that's why I said if. It's not in all situations that you can avoid. Okay, even with the quotient rule, I told you, if the denominator contains a binomial, okay, and one of the terms containing your variable, you cannot avoid the chain rule. Did I say it? No, the quotient rule, I should say. You cannot avoid that. And even with this one too, okay, we can give you questions that you cannot avoid. And that will be a situation where you cannot expand. Or, okay, the power will be too huge that if you expand using the binomial theorem before you differentiate term by term, you will waste your time. It will not be convenient for you to do so. Okay, so please take note. So we are going to, okay, build our understanding. This is the first one. We'll keep on the first set of examples pretty, okay, because the powers are, what do you call it, pretty powers. All right, okay, so Prof. Gideon.
Mr. Ekman, please, we're saying something about the equation, the one you solved at the other side.
This one.
Right side.
The rough work here, just to verify if you use the expanded version.
Hello, sir.
Yeah, I can hear you.
Okay, so because saying at that side, we're saying if we use that way, we are wrong. Say, Mr. Can you come again on that point?
No, I said, okay, per the nature of this question, if you use it, you are not wrong. Okay, only that because I'm treating this question under the composite function or the chain rule, that's why I handle it from this perspective. However, if it's in a general question and you are asked to differentiate this with respect to x, you can go this route. So it means this way and this way will go. Only that I would advise you, okay, if you are not restricted and if you can expand and differentiate term by term. So if we're not restricted, this would have been the best or the ideal way. But if you are restricted in using the composite function rule or the chain rule, then it means if you use this method, you'll be wrong because the question specifically asks you to use the composite function rule, not this. This one has nothing to do with composite function rule. Do you get the point now?
Yes, sir, please, thank you.
Oh, you are welcome. All right, so now let's move on to, okay, the B. We are going to solve almost all the questions here. My target is to at least finish with the question 1. Okay, so B. Okay, so B, what are we giving f of x? Okay, and please take note. Nowhere here should you leave any line between your steps. Okay, you move from one line to the next line. It's when you are moving from a sub question A to B that you leave a line. Those of you who are still doing that, okay, please be very, very careful. This, you don't have to be a rocket scientist. I mean, you don't have to be extremely good or good in maths before you can obey this. This has nothing to do with maths. Okay, so now what do we have here? That is x, okay, minus 3, okay, sorry, minus 2, okay, cube. Okay, someone can choose to expand, okay, and you can see that the bigger the power, okay, the more work you do in your expansion. But here, I am treating this under, okay, the composite function rule, so I will never expand. None of the questions there would you see me expand. Other than that, I wouldn't be able to use that rule. So I'm taking ddx of this side, ddx of this side. But I know that ddx of this side, let me go and clear, okay, one of my, okay, so ddx of that side here will give me f prime of x. Do you agree?
Yes, please.
Okay, so f prime of x, okay, will be equal to ddx of this side. So I'm writing it, ddx, I'm differentiating with respect to x, and that will give me x minus 2, okay, cube. So my operator is affecting a function to a certain power, a binomial function to a certain power. Okay, so I have to use the composite function rule. And by that, what do I do? Bring the power down, so the 3 down. Keep your function, which is the x minus 2. Reduce the exponents by 1, which will give me, okay, 3 minus 1, which will give me 2. Okay, but that's not all times. The dot is representing time. Time ddx of what? Of my function itself, which is x minus 2. Afa?
Yes, please.
Okay, so you can still see your operator there. So until your operators or your operator all gone. Okay, you don't, okay, end. So that will give me 3 into x minus 2, the whole of that squared. Okay, let's differentiate this term by term. So that will give us
1.
1. Okay, so in effect, we are going to get 3 times 1, which you can easily multiply. So you get your 3. Okay, then into x minus 2, the whole of that squared. Again, never expand. I know some of you can expand this. Never expand because the question came in its factorized form, not in its expanded form. All correct.
Yes, please.
Okay, so that will be it for the B. Okay, now let's go and look at what the C. Please, is everyone following? Have I left anyone behind? Or if you have left yourself behind, let me know. So this is just a rough work. Okay, let me cancel it out. In fact, it's not a rough work to anything. It's something that, okay, I wanted to introduce you, but it has nothing to do with all that we are doing here. Okay, so the nature of the question. So now what do we have? Okay, C. I leave a line before I come and write C. So a sub question to another sub question, leave a line. So G of X, okay, is equal to, okay, 4 minus what? 2x, the whole of that what? To the power 4. So you can see that the bigger the power, indirectly is trying to tell you that, okay, the more work you have to do if you want to go the expansion route. If the question is open and you want to go the expansion route, okay, you know, but that you can still do it. Okay, but please take note, once you know this rule and okay, the expansion you know will take your time, go for this rule. So here we are not going to expand. So we are going to find ddx of both sides. Ddx of G of X will give us
J prime of X.
okay, J prime of X. Very good. Okay, and that should be equal to ddx of what? Of what we have on the right-hand side. So, which will give us 4 minus 2x, the whole of that to the power 4. Alpha. Okay, so now the operator is affecting a function to a certain power, a binomial function to a certain power. If it was a monomial, then that one you go back to your factory settings. If it was just 2x, to the power of okay, so here binomial to a certain power, what do we do? Bring the power down, so 4 will come down. All correct?
Yes, please.
Okay, keep your function. What's your function? 4 minus 2x. Reduce the exponent by 1. What is the exponent? 4. Reduce by 1 will give us 3. All correct? Okay, then that's not all, times ddx of the function itself. Okay, so ddx, what's our function? Help me. 4 minus 2x. Okay. Okay, very good. So this will be equal to, okay, at least 2 steps away. So you keep your 4, okay, keep your 4 minus 2x, okay, cube. Okay, then you come and differentiate this. If you differentiate this, what do we get?
2.
No.
Minus 2.
Minus 2. It's the coefficient. The coefficient is negative. So immediately you put 2 there, you are doomed. M0, A0. You get the point? Okay, so now you know you don't end here. You can multiply this monomial and this monomial. So that is going to give us what? 4 times minus 2 give us minus 8. So minus 8, then you keep your 4 minus 2x, okay, cube. That's one you don't expand. So this is how far you can go with this. How far? Are we fine?
Yes, please.
Yes,
Okay.
please.
Okay, so on that note, can I skip the D? Okay, the D.
Yes, please.
Let's do it.
Please, can we do the D?
Okay, I will do it, but won't write it. Okay, so you are going to get 2. So J prime will be equal to 2 will come down in brackets to the power 1. Then, okay, times what? In bracket 3. Because it will be DDS of what you have here, which will give us 3. So you are going to get 2 times 3, which will be 6. So it will be 6 in bracket 3x minus 2. Prof. NS, you get it? Oh,
Yes, sir.
you still want me to write?
Yeah, sir. Please let's write. So
Okay, don't worry.
I want to secure it. So yeah.
Okay, don't worry, don't worry. Okay, all right, so we'll do it. Okay, so I looked at the time then. I wanted us to skip so that we can solve all. Okay, because this is more complex than this. Okay, so
Oh, so
now,
then if it's
Sir,
bother the time, then
oh,
I'll
no
do that
problem.
one
Let's do it.
personally with you.
No, that's okay. Let's do it. Okay, is your understanding is key. So g of x, okay, is equal to, okay, 3x minus 2, okay, all squared. Okay, so here you can expand to, okay, but I've told you are not using the expansion version, route. So g prime of x, and here let's go, will be equal to d dx of what we have there. Do you agree?
Yes,
Of what?
please.
3x
3x minus 2.
minus 2 all squared. So your operator is affecting a binomial to a certain power, a function to a certain power. So you use the same, okay, power rule. Bring it down like you are using the power rule. Bring the 2 down, keep your 3x minus 2. Reduce the exponent by, say, 2 minus 1. 1, I will write it. Okay, but that's not all times. DDS of what you have in bracket, which is what you have to the power, which is 3x minus 2. Ernesto, you there?
So, yes, sir.
Okay, so now we are in a comfortable lead. This one, your operator is not affecting it, so you keep it intact. Okay, this one, your operator is affecting it. So NS, differentiate this for me. Ernesto,
Sir.
if you differentiate this, what do you get?
You still get 3x over minus 2.
If you differentiate 3x minus 2, you still get 3x minus 2.
Sorry. Sorry.
3.
Hey, Caro, the last time I checked, you were not earnest. I'm moved by the spirit also. Please allow my spirit to function. Okay, so that will give us 3. So you differentiate 10 by 10. So if you differentiate this will give you 3. Okay, then Ernesto, you need to do quite, in terms of revision, quite a work. Okay, so now, okay, so my 3 is not, it's not 3. All right, so let's go and look at what we have there. So 3, because it will be 3 minus 0. Differential of a constant will give you. So like I said, this will end up giving us 6, okay, between 2 times 3. Okay, then you keep what you have there then, 3x minus 2. This one you can easily expand because the power is 1, but okay, per the nature of the question, it doesn't warrant what expansion. Is that clear? Leave it in its factorized form. Afa, Ernesto.
Yes, sir.
Okay, all right. So 2 more questions to go. Let me see. Oh, at least we should be able to do that. Okay, we have about 15 minutes left. Okay, these 2 questions wouldn't take 15 minutes. Okay, so now E. What are we giving? F of x is equal to, okay, s squared, okay, plus what? X, okay, all cubed. So you can see that so far, your function to the power, all the one that we've solved, all our functions were linear function, linear, 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 linear. Now what we have here is which kind of function, what you have in brackets, linear, quadratic, or cubic.
Quadratic.
Quadratic. Okay, so it's quite different, but it's the same concept that we are going to use. Bring the power down, keep your function, reduce the exponent by 1, then, okay, multiply by, okay, your differential of that function that has the exponent. So now, okay, if I'm differentiating, I will say, therefore, I'm asked to find ddx of, forgive me, ddx of f of s, which we know will give us what? F prime of s, all correct?
Yes, please.
And that should be equal to ddx of this side, so I'm writing it. ddx of what? X squared plus x, okay, then, okay, cube. So my operator is affecting a function to, okay, the whole of that function to a certain power. So composite function. So this will be equal to, now what do I do? Okay, bring the power down, 3. Okay, so I'm applying the rule. That's the more reason why you don't see the ddx there. So keep the, okay, x squared, okay, then plus x. reduce the exponent by 1. It was 3. 3 minus 1 will give us 2. Is that clear? But that is not all. Times d dx of what? What you have in bracket, the function. So it will be d dx of which function?
X squared plus x.
X squared plus x. Very good. Okay, so now this will be equal to this one you maintain. Okay, then go and differentiate that. So 3 into x squared plus x, the whole of that squared. If you differentiate this, what do we get? Ernesto, I will be on you. I want to be convinced. Differentiate 10 by 10. Prof. Ernesto, you there? Just try.
Yes,
Let
sir.
me know. If you get it wrong, we are learning. I've told you, don't be afraid to make mistakes. Okay, sometimes that's how we learn. Okay, we usually learn from our mistakes. So let's go. That's why you are a student. You learn. Make mistakes and learn. Okay, so let's go. If you differentiate x squared, what do we get?
X.
Ernesto, the normal
Sir.
differentiation, bring the power down, reduce the exponent by 1.
X cube plus x.
Ernesto,
Say,
uh-huh.
I'm confused.
You shouldn't be. If you are differentiating, you are finding d dx, okay, of x squared. Okay, remember, bring the power down. The power rule. Okay, bring the power down. Okay, so the 2 will come down. Keep your variable, reduce the exponent by 1. So you are differentiating 10 by 10. So it is d dx of x squared then plus d dx of what? X. If you don't get this, then whatever you are doing here, you won't get it. Because I've told you, as for the 10 by 10 differentiation, you will see it almost in almost all the situations because you need to perfect that. That's why I said this one you can expand and differentiate 10 by 10. The 10 by 10 differentiation is the sum and difference differentiation. That's what I mean by 10 by 10. Okay, the sum and difference rule. Okay, is okay the rule that you need to perfect. And that one will always contain either the power rule or the constant rule or the constant particle rule. Okay, so let's go, Prof. So if you differentiate this, the exponent is 1. I've told you anytime you are differentiating x and that's an exponent of 1, the coefficient becomes your answer. So the coefficient of x there is +1, so +1. So that will be it. Prof. Frank, I saw your hand up. Prof. Frank, okay, or you are fine. Okay, all right. So now, okay, at this point, you can see this will be equal to, so go and, okay, multiply the ones that you can easily multiply. Someone can leave the answer this way, 3 into, so I write my pretty factors first. 3 is prettier compared to this. So all among the 3, okay, factors, 3, this and that, this is prettiest. So you come to 2x is the next one. Okay, then into the next one, which is the x squared, okay, plus x, okay, the whole of that squared. But please take note, okay, the one that you can easily multiply. So that's this one I can easily multiply. So that will give me 6x, okay, plus 3, okay, the whole of that into, okay, my x squared, okay, plus x, the whole of that squared. All correct. So meaning someone can move from here to here. I will multiply this and this to come and get this, then keep this one there. Just as we are doing here. We multiply this and this, the one that we can easily multiply, rise the result, then come and maintain the function, okay, that we have there, okay, to the new power. Is that clear?
Yes, please.
Yes, please.
Okay, very good. So now our last question. Okay, so indeed we've been able to solve all the questions here. So now let's go. Okay, what are we given? Y is equal to, okay, all right, 5x squared, okay, minus 2x, okay, to the power 4. And next to be on guard, I'm going to be on you. All right. Okay, so I've told you, don't panic. Don't be afraid to make mistake for you to be panicking. Okay, if you do mistake, I will know where your issues are and direct you to where to get that remedy. So if you need to go and revise, I will ask you to do so. So advise you appropriately. So now, okay, you are asked to differentiate what you have there with respect to x. So you are finding d dx on both sides. ddx of y we know will give us dy dx. So the question is asking us to find dy dx. Is that not it? And that should be equal to ddx of what? Of the right-hand side. And the right-hand side, what do we have? 5x squared, okay, minus 2x, or to the power 4. Okay, so at this point, we know the rule. The operator is affecting a function to a certain power, a binomial function to a certain. So bring the power down like you are doing your normal power rule. Power down 4. Okay, keep your function, which is the 5x squared. Okay, minus 2x. Okay, then reduce the exponent by 1. 4 minus 1 will give us 3. But that's not all times ddx of the function. Okay, so my ddx. Okay, of the function that you are raising to the power. So 5x squared, okay, minus 2x. Okay, oops, what did I do? Forgive me, minus 2x. So let me clear the whole of this. My professors, I hope you are following.
Yes, please.
So minus 2x. Okay, so now this will be equal to, okay, so you keep this, your operator is not affecting this. So you keep your 4, okay, into 5x squared minus 2x, the whole of that cube. Okay, then we are going to differentiate this. Okay, so Prof. Ernesto, okay, let's go. So the rest you watch our back. Prof. Ernesto, are you there?
Yes, sir.
So let's go. We are differentiating, bring the power down. So the 2 will come down and multiply the 5, and that will give us
10x.
10x. Okay, so 10x, you reduce the exponent by 1, 2 minus 1. So that will give us 1. You don't write it.
Yeah.
So let's come to this one. What would that give us if you differentiate this term?
It will be 2x.
No, you cannot differentiate 2x and get 2x. This is minus 2x.
Then minus 2x raised to the power, the x will be inverse, like x raised to the power minus 1.
Why minus 1? This, I told you, if you are differentiating and, okay, the x, the power, the term, the power is 1. What should be the result?
0.
The result should be the coefficient. It will be 0 when it is just a constant. Because if I'm differentiating, okay, x is the power 1. I'll bring the power 1 down, keep my x, reduce the exponent by 1. So it will be 1 minus 1, which will give me 0. Any number to the power 0 is what? 1. So that will give me 1. It will not give you negative 1 for you to be inverse. If it's negative 1, then it means you had, okay, what 0 there, then you subtracted 1. But the original power is 1. So if you subtract 1 from the original power, you get 0. That's why I said anytime you are differentiating, you have ax, okay, and you differentiate, you always get your a. So here, if you differentiate, the a is the coefficient, you get minus 2. Go and, okay, revise the first lesson, okay, on what do you call differentiation. So it means you from lesson 1, that's where your issue is. If you don't deal with that issue, you will struggle throughout all that we are going to do. Because all that we will do, we use the rules that we learned in lesson 1. That's why we said the basic rules. So if your basic rules are not strong, okay, definitely you will struggle. So at this point, you know, okay, we are a step away. We can multiply this and this. Prof. Ernest, are you fine with this explanation?
Yes, sir. I
Okay,
think
so
I'll have to go on the revision.
yes, I know. I don't think I know you have to. So go, go and revise. Go and revise. Okay, so use the weekend to catch up. Okay, once you get it, the rest will be very easy. So this times that, okay, I'm going to get 40x, so I'll get my 40x. I put it because I'll get a binomial minus 8, the whole of that multiplying this, and that will give me 5x squared, okay, minus 2x, okay, cube. So this then becomes my final result. Safa.
Yes, please.
Okay, so at least we've been able to reach our target. From Gideon.
So this means whenever you get to that step, you So you see the last step, like our final answer. The
Yes.
second bracket, the one with the 5x squared minus 2x all to the power 3. So it means you are sending it back to the question form, but then you reduce the exponent by 1.
Yes.
So that's what indirectly we are doing. But if you reduce the exponent by 1, that's
Okay.
not all. There will be two factors that will multiply. One of the factors will be the power that you brought down, and the other factor will be, okay, the differential of the function that you have in brackets. So you can see that all along you are getting three factors. The power that you brought down, the function itself, then you reduce the power, and the third one will be the differential. So you always have three factors. One is the coefficient, the power that you brought down. The second will be the function with its reduced power by 1. Then what? The next will be the differential of the function itself. So you always have three factors. So you can see that we have three factors here. Three factors. The first one is the power that was brought down. The second one is the whole of the student's power because you reduce the exponent by 1. The third one is the differential, okay, of that. So three factors. But okay, some of the factors you can easily multiply. So the one that you can easily multiply, you multiply. And that will be either the power, okay, and what do you call it? I mean, the power and the one that you differentiated usually will be the ones that you can easily multiply. Okay, Prof. Caroline.
Mr. Akman, please, I wanted to say something.
Okay, go ahead.
Please, I think I've noticed a certain pattern in the way we are solving the things, like
Mm-hmm.
looking at these sets of examples. Please, I noticed that all the questions with the linear, like the linear equations here, the answer we get, like it's somehow connected to the question. Like you can solve it off head. Like if
Yes.
someone asks me, yes,
Yes, or
because
even
you
all
can
the
see,
ones that you have, the not to count you, all the ones that you have, that you can solve it off head. But you can see a
yes,
particular pattern if it is linear.
yes, and if
Okay,
it
if
is
it is
quadratic,
linear, okay, it will just be okay, you using the power rule. Okay. However, okay, the sign will come from the coefficient of your linear term. I mean the variable term. So you can see that this gave us 2 into x minus 2 to the power 1. Okay, 3 into x minus 2 squared. Okay, because the coefficient was what? Positive 1 here. The differential gave you positive result, so it will not change the sign. But this one, the differential gave us negative 2, so it will give us a differential, okay, I mean the sign to change. I don't know whether you get my point.
yes, please.
Okay, was that not the pattern that, but you have to be very careful, especially the sign. If you think
Yes,
maybe the pattern, this one will give you 4, okay, into you reduce the power and you end there, you'll be wrong. Because if you differentiate this, okay, the coefficient will not be, I mean, your result will not be 1. So it means it will affect the function itself, your result. But this one, if you differentiate that term, that factor that must be considered. If you don't consider it, will not change your answer. But here, if you don't consider it, will change your answer. You get it?
yes, please.
All right, okay. Any other? I saw, okay, another hand up. So, okay, so if that's the case, okay, then I would want to bring the curtains down here. You are not leaving, take notes. I've been taking the final attendance. Okay, so, okay, on this note, thank you very much for making the class very interactive. Okay, if you realize that you need to go and revise, the videos are always available. Okay, so go back to the lessons that you think you need revision on, then revise. Okay, otherwise, okay, please, you wait for your assignment. Okay, so subscribe to my YouTube channel if you haven't. Okay, like, okay, and share as well. Okay, so thank you very much. God bless us all.